Hey guys, and welcome back to Level 6 Math. Today we're looking at Lesson 80 in our Saxon Math. I'm Mr. C, and today we're looking at using a constant factor to solve ratio problems. Now, this is something we've been doing all along. You know the math to do this, but this gets a little tricky because we're going to use word problems, and we're going to do it in a tricky way. This is something Saxon loves to do, and it's actually doing you a favor because I've seen that on end of year, like high stakes assessments, they do problems like this. It's stupid because the way that it's worded and the way it's set up is not the way we do this in the real world, but this is the way it shows up on tests. So being able to do today's homework is going to help you a lot with tests that you'll have later on. So we'll go through it. It's a good review, good practice. So let's look at this ratio problem. To make green paint, the ratio of blue paint to yellow paint is 3:2. That's the ratio, all right? So that's the important thing, is this ratio 3:2, and we want to look at a constant ratio. So for 6 ounces of paint, so if it's 3:2 and we have 6 ounces of yellow paint, how much blue paint is needed? Now they set this up in a box, and this is really helpful. You don't necessarily have to set it up in a box. Before, we just would set this up as a problem is something like 3/2 equals number over 6, right? It's the same thing. We're just solving for that. So we have to think, how many times does 2 go into 6? 2 times 3 equals 6. And for it to be a constant ratio, we have to have the same thing on top. So we're going to do our 3 times 3. And 3 times 3 equals 9. So we know it's going to be 9 ounces of blue paint. But let's look at how Saxon tells us to think through this. So we see 2 uses for numbers in this ratio problem. One is to express a ratio, the other is to express an actual count, okay? That's this actual count. So the ratio box helps us sort the 2 uses by putting the ratios in one column and the count in the other. Then we're told that the ratio was 3:2, so we just fill in those boxes. We place those numbers in the ratio column, and then that's what we're given. Then we're given an actual count of 6. So now we have one unknown. We're asked to find the actual count, so that's what's empty. Now we actually solve it by using a constant factor. If we multiply the terms of the ratio by the constant factor, we find the actual count. So recall that a ratio is a reduced form of an actual count. So if we determine the factor by which the actual count was reduced, we can recreate the actual count. What does that mean? Probably something awesome. It means we need to put in the constant factor. How do we know what the constant factor is? So we have to figure out 2 times what equals 6. So we see that 2 can be multiplied by 3 to get 6. So I guess that's our constant factor, is 3, right? So that's what we do. We just multiply it by 3, which is what we did before. It's the same as just setting that up as an equation. All right, let's do another one. We're going to set this up in a box, just like we did the first one. Sadly, the ratio of flowers to weeds in the garden is 2:5. Oh, lots of weeds. There are 30 flowers in the garden. How many weeds are there? So we can set this up in boxes. We've got a ratio, 2:5. Actual count of flowers, 30. How do we know to put flowers on top and weeds on the bottom? Because they told us it's ratio of flowers to weeds. Flowers came first, so that's going to be the 2. So we just set that up, and then we say 2 times what equals 30? 2 times 15. The other way we could do that is use an opposite equation and just divide 30 by 2. So if we don't know how many times 2 goes into 30, we can just divide 30 by 2, we get 15. And then we just multiply 5 times 15, that's our constant factor, and we get 75. So 75 weeds in the garden. So you need to go out and do some weeding. Don't make your mom do it. Don't make your dad do it. You can go ahead and do it. Just get it over with. 75, you know, it's going to take you like 5 minutes if you work hard. So just get those weeds. And stop whining about it. All right. Now, that's our practice. That's it for today. So you're just going to have to practice. Really, today's practice is in thinking about how they set up the problem, putting it in a ratio box, having that constant variable, and just practicing doing that. So the more you practice it, the easier it'll get. It's going to click for you. It's going to make more sense. Good luck. Bye-bye.